Hey, welcome to the Explainer. Today we're going to tackle a core concept in Python that honestly opens up a whole new universe of possibilities with data, the nested loop. Seriously, if you've ever wanted to work with grids, tables, or even image data, this is the skill you absolutely need to master.
So think about it for a second. A spreadsheet, a chessboard, the pixels on your screen. They all live in a two-dimensional world, right? They've got rows and they've got columns. But a computer program usually just thinks one step at a time, in a straight line. So how in the world do you teach it to navigate a grid? And that right there is the secret sauce. It really is that simple on the surface, but this one technique is the key that unlocks everything. It's how computers process 2D data, it's how they draw complex patterns, and it's how they compare massive data sets against each other. All right, let's get right into the mechanics of it. We're starting with the absolute foundation, what a nested loop actually is, and maybe more importantly, how a computer thinks its way through one, step by painful step. So here's the official definition, a loop that runs inside another loop. But forget the jargon, it's all about that one crucial rule. The best way to think about it is like a clock. The minute hand has to take a full 60 seconds, a complete cycle, before that hour hand is allowed to move just one little tick forward. That is exactly how nested loops work. The inside loop does all of its work first, and only then does the outside loop get to take its next step.
Okay, let's actually walk through this together. Look at the outer loop, I. It starts at 0, and it just waits. It kind of hangs out there, while the inner loop, J, has to run its entire course, going from 0 to 1. And only then, after J is all done, is I finally allowed to move up to 1. Then the whole process resets. The inner loop runs completely again. That's why we get 3 times 2 for a grand total of 6 iterations.
Okay, so we've got the logic down. Now for the fun part. Let's see how this abstract concept of numbers ticking up can actually build something you can see, something tangible. We're about to go from a boring table to creating actual visual patterns. And check this out. This is a perfect illustration of the power you have. On the left, you've got a basic rectangle. The outer loop runs 4 times for the rows, and the inner loop just does its thing, a fixed 5 times for the columns. Easy enough. But look at the right. One tiny, tiny change. We made the inner loop's range depend on the outer loop's value, I plus 1. Now its behavior is dynamic. So when I is 0 in that first row, it prints 1 star. When I is 1 on the second row, it prints 2. And just like that, you've carved a triangle out of a rectangle. All right, your turn. Quick challenge for you. You have that same row and column logic we just used. How would you adopt it so that instead of just printing a star, it prints the result of the row number multiplied by the column number to make a full-on multiplication table? And boom, here is that beautiful result. All you have to do is use the outer loop variable, I, as your row number, and the inner loop variable, j, as your column number. Then at each step, you just print I times j. And you get this perfectly structured, super useful table. Now, making cool shapes is fun and all, but that's not the main event. The real magic happens when we apply this exact same logic to handle real-world data structures. So in Python, a grid is represented in a really intuitive way. It's just a list where every single item inside is another list. Just think of it like this. The big outer list holds all of your rows, and each one of those little inner lists is a row with all its data. Okay, so how do you pluck just one number out of that grid? Well, you just need its coordinates. If we ask for a matrix of 1, we're asking for the second row, which gives us that whole list, 4, 5, 6. Now from inside that list, if we ask for index 2, we're grabbing the third element, which is 6. Row first, then column. Simple as that.
All right, so we know how to build these 2D lists and how to grab stuff from them. Now let's put our nested loops to work and actually do something useful, like summing things up, filtering them, and a whole lot more. This right here, this is your 3-step playbook for pretty much any 2D list. You should burn this into your brain. Step 1, an outer loop to grab each row. Step 2, an inner loop to go through every single element in that row. And step 3, inside that inner loop, that's where you do your thing. Add it, check it, change it, whatever you need to do to that element.
Let's see that playbook in action. So step 1, our outer loop grabs the first row, 10, 15, 20. Step 2, the inner loop looks at 10, then 15, then 20. Step 3, what's our job? A simple check, is the number even? If it is, we add it to a new list. We just repeat that for all the rows, and as you can see, we correctly find the 4 even numbers hidden in our data. Here's another super common problem this solves perfectly: finding out what 2 different lists have in common. The logic is just a perfect fit. The outer loop grabs one element from the first list and holds on to it. Then, the inner loop just races through the entire second list, comparing that one element to every single thing in the second list. If it finds a match, bam, you found an intersection. Okay, we've covered the mechanics, we've made some patterns, and we've processed some data. Let's lock it all in with a quick quiz to see what stuck with you. All right, first one up. Take a good look at this code. It's only a single loop, but it's using a little trick. What do you think happens in Python when you multiply a string by a number? And the answer is C. Yeah, this is a fun little Python quirk. It's not mathematical multiplication, it's string repetition. So when I is 2, string of 2 times 2 gives you the string 2, 2. When I is 3, you get 3, 3, 3. And that creates this very specific pattern. And for our final question, this should definitely look familiar. Which one of these code blocks uses that nested loop logic we talked about to properly build a right triangle? And you got it, the answer is B. This goes right back to that key pattern. The number of stars printed by the inner loop is directly controlled by whatever the current row number is from the outer loop. That's exactly how you get that diagonal edge for the triangle. So you see, nested loops aren't just some random piece of syntax. They're a way of thinking. Once you start seeing the world in rows and columns, you unlock the logic behind everything from game boards to complex image filters. The core idea is so simple. For every one step the outer loop takes, the inner loop has to run its entire journey. Now that you have this tool, the question isn't just what you can build. I'll leave you with this. What happens when you get brave and add a third loop to think in 3 dimensions? That's a challenge for you to explore. Thanks for joining this explainer.